Yes, Brant, which one?
19.
Number 19, as fate would have it. Simplifying that expression, Brant, what do you suppose you have to do? What property are we going to start off with here? You need to get rid of these parentheses. So you're going to take the 3 and multiply it by both of those. So you end up with 3x plus 6, correct? Then you're going to take the 2 and multiply by both of those, so you're going to get plus 2x minus 6. Stop me there if that didn't make sense. Now you're done with the parentheses. By the way, there's no equal sign, so you're not getting an answer. You are just simplifying this. So combining like terms, 3x's plus 2x's, Brand? 5x. And 6 minus 6?
0.
Nothing. That's the reason you're left with just a 5x. Carter Westfall.
How do you get number 1?
Number 1. Scale of a model car is 1 inch equals 5 feet. If the model is 9 inches long, how long is a car? Did you, sir, draw the ratio box out?
No.
Have we never done ratio boxes for models before? Anybody help me here? We have? All the time?
Yes.
So it looks like this. You got this. This is your model. Is that right? Model here, actual there? No. Sorry. Well, yeah, we can do it there. Model here, actual there. What things are we comparing? The scale is 1 inch equals what? 1.5 feet. Make sure you label those correctly. 9 inches goes, is that the model or is that the actual?
Yeah.
9 inches is what? No, it's the model. If the model is 9 inches long, that goes here. You just want to know what this is. So it's just that equal fraction thing. 1 over 9 equals 1.5 over what number? So you are simply going to do this. Oh good, look at its n by itself. You just take 9 times 1.5, which is 13.5. 13.5 feet. All very simple if you do the little ratio fraction scale box. It's all the same. Only Carter Altenberg, the names have changed. Yes, sir.
What is the answer for?
To 4? The answer to 4 is 314 centimeters cubed. Carter Westfall.
How do you get 13?
You graphed both of those?
Yes.
You did you? What did you get for an answer?
I got
Did you use a ruler, sir?
yes. Oh, I didn't draw a line.
What's that?
I did not draw a line.
Huh.
I must have not had a ruler at the time.
Well, that would explain why you didn't get an answer with it. Interesting how that works. So you're questioning why you didn't get an answer when you didn't do the problem? That's an interesting thought, but it's, you might as well do it nonetheless here. First of all, what form are these equations in, ladies and gentlemen? What types of linear equations are they? Wade Davis, this is?
Y-intercept. Or slope-intercept.
Slope-intercept. And it's called slope-intercept because it gives you the intercept and it tells you the slope. Here's where it crosses the y-axis, and this number in front of the x, which happens to be nothing, well, it's a 1, is the slope. So this one crosses at -1, so here I put a dot at -1, and my slope is positive 1 over 1, up 1 over 1. And you can keep doing that. It would be a good idea to keep following that slope up just so your line gets more accurate. So there's the graph of that line. So we'll put it there. Please do it with a ruler. I can do it freehand just try something up here. Same thing for the second one. Crosses the y-axis at negative, or at positive 3, 1, 2, 3, but this one has a negative 1 over 1 slope. So instead of going up 1 over 1, it's going down 1 over 1. It has a negative slope, so down 1 over 1, down 1 over 1, down 1 over 1. Did I miss that? Anyways, it's going to cross. Looks like it crosses here at what? Is it 2, 1? Yeah. 2, 1. Should have crossed there. What did I do? Down 1, 1. Yeah. Anyways, your lines will cross at 2, 1. If you draw them straight up. Accuracy does count on that, so freehanding is kind of bad. Grant!
Hey, what is that?
Lucky number 7. Number 7. The dimensions of a cube are double. The volume of the new large cube is how many times the volume of the original? Question, do you need to draw the cube?
Yes.
Nope.
Oh.
You can if you want,
Yay.
but you're asking how one thing compares to another when you're talking about scale factor, right? I suppose you might, I mean, it doesn't really matter. What is my scale factor? What am I doing to the small cube, to the big cube, what am I doing to it?
Times 2.
What's that? Say that again?
Times 2.
Times 2. So if this is 1, this is 2. So my scale factor is what? 2, right? When you talk about volume and how much bigger something is, what do you do to the scale factor to get the new volume? By the way, what is the volume of this cube? 1 times 1 times 1 is?
1.
This one is 2 times 2 times 2, which is?
8.
What do I multiply this by to get that? 8. But that is the scale factor cubed. You don't really have to draw the one. You just know. If you know the scale factor, their areas are the scale factor squared compared to each other. The volumes are the scale factor cubed. Missed that. You get a 3. 2 times 2 times 2 is 8. You don't even really need to draw. And that's why they didn't give you dimensions there. It should just be something there. Just like we talked about this before. Any other questions? I don't get on a tangent, or an 11th, or a not tangent. Carter Westfall.
How do you get 8? 8. 8.
Problem 8?
Yes, 8. Problem 8.
Well, do you know how to find the perimeter of rectangles?
Yes.
How do you do that?
Oh, I don't know size.
Perimeter equals side plus side plus side plus side, right? So what are the sides?
They are 2x plus 3
Alright,
and x minus 1.
that's only 2 of them.
And then the other one is 2x plus 3.
Mm-hmm.
The other one is x minus 1.
So there's your perimeter, you just need to simplify it. Put all the x's together, how many x's do you have? 2x plus x plus 2x plus x.
Plus x.
How many x's does that give you?
6x.
6 x's. Bam. And then putting your numbers together, 3 minus 1 plus 3 minus 1 is?
3 minus 1 is 3. This is 4.
There's your answer. That's why it asks you for an expression, because it's not like a real number. It's not like 15 or 20, it's 6x plus 4. Whatever x is, multiplied by 6 and add 4 to it. Fake!
For number 16.
Number 16. Wait, let me get there. Is that up on top? Yes. How much money is 6 2/3 or $24?
What would you change 6 2/3 into?
That's an interesting question, ladies and gentlemen. I'm guessing it's not on your reference sheet,
It is, but it's a repeating test.
but is it given as a fraction on your reference sheet? Or no?
1 2/3.
No, it can't be 1 2/3. It doesn't give the fraction?
2/3.
Huh? 2/3 is a fraction, just 66 2/3%. This is just 6 2/3%. Isn't it?
Yeah.
2/3. The fraction 2/3 as a percent is 66 2/3%. That's not what this is. This is 6 2/3%.
I got you. I just did 20 over 3 times 24 over 1.
Yeah, that's what I did.
Huh?
20.
Yeah. Well, one thing you can always do to see what fraction this actually is just take it times, take 6 2/3 times 100, and that'll tell you what fraction it is. In other words, you said, that's what you said. You said you took 18, 19. This is 20 over 3 times 100, which is 2,000 over. Wait. I'm sorry, is that, yeah, times 100%. Oh no, that's changing 6 2/3%. Wait, what is 6 2/3 as of, oh, it's this. I'm sorry, you have to divide by 100, which means is you multiply by 1 over 100, which means this crosses off with that down there, and you get, the fraction for 6 2/3 is 1/15, which may be good to know because that's probably the number they're using tomorrow, so you may want to jot that in your notes. So you just take $24 times 1 over 15, which is, I'm sure, what you got, right? What number goes into this? 3, 5, 8. 8/5 dollars, which is 1 3/5, or $1.60, because you're looking for money. So write in your notes, ladies and gentlemen, that 6 2/3% is 1/15. I'm guessing it's going to come up tomorrow. So if I were you for problem 16, I would just say multiply by 1/15. That's what 6 2/3% is. Other ones, is that all you have? It's just 3 questions on this one.
1, 2, 3, 4, 5, 6 questions.
What?
6.
Total? 6?
Maybe. 6 questions.
Nothing? Going once? Going twice? Interesting. Now, here's the spiel is,